Right now, millions of microbes in your digestive tract are, well, they're actively manipulating your brain chemistry so that you'll crave a cup of coffee tomorrow morning.
Yeah, it is a wild concept.
I mean, you probably think you're drinking it for energy or focus or, just because you like the taste.
Right, exactly.
But there is a very real biological chance that you are simply serving as a delivery system, like completely compelled to feed a specific colony of bacteria exactly what they want.
It completely shatters how we view the morning ritual, doesn't it?
It really does.
We have this incredibly simplistic view of coffee as a direct, straight line to the brain. You drink it, you wake up.
Yeah, cause and effect.
But it's actually taking a massive, highly complex detour through the gut microbiome first.
Okay, let's unpack this because today we were exploring a massive, brand new clinical study published in April 2026.
And a really meticulously designed one, too.
Right. And what makes this so exciting is that this isn't just an observational survey, where researchers just hand out questionnaires asking people to guess how much coffee they drank last week.
Oh, those are the worst. The data is always so noisy.
Exactly. This study maps exactly how habitual coffee intake shapes the microbiota-gut-brain axis. They literally track the biological cascades from the cup down into the colon and all the way back up to the cortex.
If we connect this to the bigger picture, the microbiota-gut-brain axis is basically a bidirectional superhighway. The gut and the brain are constantly texting each other.
And today we're intercepting those text messages.
Exactly. And the clinical design is what makes this research so definitive. They took 62 healthy adults right in the middle of life, aged 30 to 50.
Okay.
Half were strict non-coffee drinkers, and half were moderate habitual drinkers, meaning they consistently consumed about 3 to 5 cups a day.
So a pretty standard habit for a lot of people.
Right. But rather than just looking at their baselines and calling it a day, the researchers forced the coffee drinkers into a hard physiological reset. They made them quit cold turkey for 2 weeks.
Ouch.
Yeah. And then in a blind trial, they reintroduced either regular caffeinated coffee or decaf.
Which is such a brilliant way to isolate the variables. I mean, coffee isn't just caffeine, right? It contains hundreds of bioactive plant compounds.
Thousands, actually, yeah.
Wow. So by splitting the reintroduction into caffeinated and decaf, we finally get to see what the caffeine molecule does versus what the actual roasted bean itself does.
Exactly. It's a vital distinction.
So just to keep this really intricate protocol straight as we go through the data, let's frame the study in 3 distinct phases. Let's call them base, break, and brew.
Base, break, and brew. I like that.
Yeah, so base is the baseline measurements. The break is the 14-day washout to clear their systems. And the brew is that 21-day reintroduction phase.
That is a perfect framework. So let's start with the base phase. Because before the researchers even looked at a single psychological or behavioral metric, they looked deep into the participants' genetics.
Right, they went straight to the DNA.
Exactly. Specifically, they sequenced the ADORA2A gene.
And that's the gene that governs your adenosine receptors, right?
Spot on. So for those who might not know, adenosine is essentially the cellular exhaust that builds up in your brain throughout the day.
It's the stuff that makes you tired.
Right. It eventually fits into these specific receptors to make you feel sleepy. And caffeine's entire main trick is that it is shaped just like adenosine.
So it's an imposter molecule.
Exactly. It slots into those receptors and completely blocks the sleep signal from landing.
Right. So your genetics dictate how those receptors are actually built and how inherently sensitive you are to caffeine. And looking at the data, the researchers focused on 2 specific single nucleotide polymorphisms on that gene.
The SNPs, yeah. Specifically RS229-8383 and RS575-1876.
Right, those tiny single-letter variations in the DNA code. But I have to admit, I was completely thrown by the results here.
Oh, the genetic flip. Yeah, it's fascinating.
Because, I mean, previous research seemed to firmly establish that if you had a specific variation, the TT haplotype, it usually meant your body metabolized caffeine in a way that naturally led you to drink more coffee.
That was the old consensus, yeah.
But this 2026 cohort showed the exact opposite. The non-drinkers were the ones who carried more of that specific genetic variation.
It is a massive genetic curveball. And honestly, it highlights one of the most crucial lessons in modern biology.
Which is?
Genetics are not always destiny.
Right.
I mean, your DNA provides a structural blueprint, sure, but your environment, your daily habits, and your social context, they act as the contractor actually building the house.
Love that analogy.
Thanks. What we are seeing here is the power of habit to completely override a genetic predisposition.
But wait, how does that actually happen mechanically? Are we talking about the brain just like physically altering its receptor density to match the environment?
Exactly that. It is primarily driven by receptor downregulation and neuroplasticity.
So the brain changes its own hardware.
Yes. Even if your DNA dictates an extreme sensitivity to caffeine, meaning a single cup should logically make you so jittery that you never want to drink it again, environmental pressures can push you past that initial biological barrier.
Like pushing through the jitters.
Exactly. Maybe you grew up in a culture where coffee is a central social pillar. Or maybe you took a job working night shifts and just had to stay awake.
So you force the habit.
Right. And over time, your brain adapts to this constant flood of caffeine by reducing the number of active adenosine receptors or by changing their sensitivity. The daily habit literally rewires the hardware, rendering that initial genetic sensitivity completely moot.
Wow. So behavior absolutely trumps biology when given enough time. That makes total sense. And speaking of behavior, their baseline psychological profiles were drastically different before anyone even changed their diet.
Yes, the psychological baselines were very revealing.
Yeah, the coffee drinkers scored significantly higher on impulsivity metrics, specifically on the UP-PSP scale, which measures sensation seeking. They were biologically and psychologically more driven toward novelty and external stimulation.
They were also far more emotionally reactive. They measured this using the ERS, the emotional reactivity scale.
Yeah.
The non-drinkers, conversely, exhibited a much higher baseline of cognitive stability.
They were just generally calmer.
Right. They simply weren't hunting for that next hit of environmental stimulation.
It is incredible to step back and look at what we've uncovered just in this baseline phase. So let's do a quick recap so we have all the pieces in place.
There you go.
Number one, we have a 3-phase clinical protocol: base, break, and brew. Number two, we saw environmental habits completely rewrite a genetic blueprint regarding those adenosine receptors.
Right. And number three, we're seeing that those habitual coffee drinkers have a biologically driven need for novelty and a higher baseline impulsivity.
It really forces you to look inward. And I'd pose this directly to you listening right now. When you crave that morning cup, are you actually seeking physical energy? Or is your brain secretly just hunting for a sensation-driven dopamine hit to satisfy an inherently impulsive baseline?
Oh, that is a tough question to ask yourself at 7 a.m.
It is, but that is the exact tension the researchers wanted to probe, because if their baseline is defined by high stimulation and emotional reactivity, what happens when we completely remove that stimulus?
And that brings us to the break phase, the 14-day washout where the coffee drinkers went cold turkey.
And going cold turkey for 2 weeks from a 5-cup-a-day habit is brutal.
Oh, absolutely. We know from the physical reality of habituation that withdrawal symptoms like deep drowsiness, systemic fatigue, and those awful vascular headaches, they usually peak around day 4.
Because all those adenosine receptors we just talked about are suddenly empty and screaming for stimulation.
Right. And that causes the blood vessels in the brain to dilate, causing the headache.
Yeah.
But what really stood out in the data here was the craving metric.
Yeah, the cravings didn't drop.
Right. Even after the physical headache subsided after the first few days, the psychological desire for the coffee remained completely flat and steady for the entire 2 weeks.
While their physical impulsivity metrics plummeted back down to match the non-drinkers, the ghost of the habit stayed anchored in their minds. But, the most revealing part of this washout phase wasn't just how they felt.
What was it?
It was how their bodies physically processed stress without their usual chemical crutch. What's fascinating here is the SECPT protocol.
The socially evaluated cold pressor test. I really want to highlight the mechanic of this because it is brilliantly cruel.
It really is the gold standard for inducing stress.
It's not just sticking your hand in a bucket of ice water. Participants are forced to submerge their hand and wrist into 0 degrees Celsius water for 3 full minutes.
Which is incredibly painful.
Very painful. But simultaneously, they have to stare directly into a video camera, while a researcher coldly observes and evaluates their facial expressions. It marries acute physical agony with acute social judgment.
It's scientifically designed to trigger an undeniable spike in the HPA axis.
And that's the hypothalamus pituitary adrenal system.
Right, exactly. That is the internal cascade that ultimately floods your bloodstream with cortisol, which prepares your body for a fight or flight response.
It's basically like having to give a public speech while holding a snowball barehanded.
That is a hilarious and perfectly accurate analogy, yes.
Now, my logical assumption here was that the coffee drinkers, especially while in the middle of a stressful washout phase without their primary coping mechanism, they would suffer a massive cortisol blowout compared to the calm, stable non-drinkers.
That's what anyone would hypothesize.
Right. But when I looked at the charts, their cortisol awakening response, or RR, and their SECPT cortisol spikes were literally identical to the non-drinkers. There was absolutely no statistical difference.
It feels completely counterintuitive, doesn't it?
Totally.
If you dump a powerful central nervous system stimulant into your body every single day for years, your stress system should theoretically be frayed or hyperreactive.
You'd think so.
But what we are observing is a profound physiological adaptation. Over years of habitual use, the HPA axis recalibrates. It has to. If it didn't, habitual coffee drinkers would exist in a perpetual, exhausting state of panic.
Right. The body just wouldn't survive it.
Exactly. They develop a partial systemic tolerance. So even when faced with extreme external stressors like the socially evaluated ice bucket, their core stress systems don't overactivate.
So their core stress hormones completely adapted to the habit. But the immune system story, that is where things shift from behavioral to deeply biological.
The immunological data is arguably the most important part of this entire study.
Yeah, the researchers tracked a variety of immune markers, and the habitual coffee drinkers had a significantly lower baseline of CRP and higher levels of IL-10.
Let's break down those mechanisms, because this is crucial. CRP stands for C-reactive protein. It's an acute phase protein. You can think of it as the body's systemic fire alarm.
Okay, fire alarm.
When there is tissue damage or inflammation anywhere in the body, the liver pumps out CRP. The habitual coffee drinkers had incredibly low levels of it, meaning their internal fire alarms were quiet.
And what about IL-10?
On the other side, IL-10 is a highly potent anti-inflammatory cytokine. It suppresses the immune response to prevent tissue damage.
So if CRP is the fire alarm, IL-10 is the fire extinguisher.
Perfect way to look at it.
The coffee drinkers are walking around with fewer alarms ringing
Yeah.
and a massive surplus of extinguishers on hand. And the proof of this really came during the 14-day break.
Oh, the withdrawal data here is stunning.
The moment they quit drinking coffee, their CRP levels spiked. And another aggressive pro-inflammatory marker, TNF-alpha, that jumped up too, removing the coffee literally dropped an immunological shield.
Exactly, and the researchers didn't just observe this in the standard blood tests. They proved the mechanism through a highly specific ex vivo simulation.
Oh, this was my favorite part of the entire methodology. Ex vivo, meaning they did this outside the body.
Right, they draw the participants' blood, isolate it in a petri dish, and then introduce LPS.
And LPS is lipopolysaccharide, right?
Yes, it's a molecule found on the outer cell wall of certain bacteria. When you drop LPS into a blood sample, the immune cells recognize it, assume there is a massive bacterial infection, and launch a full-scale inflammatory counterattack.
Like a biochemical drill.
Exactly. They start pumping out inflammatory cytokines, specifically IL-6, to rally the body's defenses. But here is the kicker. The blood drawn from the participants when they were actively consuming coffee behaved completely differently than the blood drawn during their washout phase.
How so?
The coffee consumption literally halved the secretion of IL-6.
Halved it. It is as if the polyphenols and compounds from the coffee are acting like diplomatic envoys in the bloodstream.
I like that.
They see the fake bacterial threat, intercept the immune cells, and somehow signal, hey, stand down, we don't need a massive inflammatory panic here.
They actively modulate the panic response down to a whisper.
It completely changes how I view my morning routine. I mean, knowing that it's actively suppressing systemic inflammation at a cellular level, it feels less like a vice and more like a preventative therapeutic.
Which perfectly sets up the ultimate question for the final phase of the study.
Let's do another quick recap before we jump into that.
Sure.
So, bullet 1, withdrawal from coffee peaks at day 4 physically, but the psychological cravings stick around. Bullet 2, coffee doesn't alter your core stress hormone resilience at all. You build a tolerance.
Right.
And bullet 3, coffee acts as a powerful anti-inflammatory shield, lowering your internal fire alarms and boosting your fire extinguishers.
So does knowing that coffee acts as an immune system fire extinguisher change how you view your daily habit?
It absolutely changes it for me. But as you said, it brings up the biggest question. If the habit is providing this incredible immune shield, is it the caffeine molecule doing the heavy lifting or the complex chemistry of the roasted bean itself?
And that brings us to the brew phase.
Here's where it gets really interesting. The 21-day reintroduction, where the coffee drinkers were blindly split, half received regular caffeinated coffee and half received decaf. Neither group knew what they were drinking.
And the psychological and cognitive results were completely divergent.
Let's look at the caffeinated group first.
Okay, so the caffeinated group exhibited a significant decrease in overall psychological distress, and they performed vastly better on complex cognitive tasks, specifically the PACE-AT test.
The Paced Auditory Serial Addition Test, basically a brutal cognitive stress test where you have to constantly add numbers under time pressure.
Right, it measures sustained attention and processing speed, and the caffeinated group aced it. This aligns perfectly with what we know about caffeine blocking adenosine to maintain alertness.
But there was a really crucial finding regarding anxiety, right? They measured it using this STAI, the State Trait Anxiety Inventory.
Yes, caffeine is universally known as an anxiogenic. It creates anxiety. But this group actually saw a reduction in their baseline anxiety.
Wait, a reduction? But how does a stimulant lower anxiety?
Because we are dealing with habituated users, their brains have already downregulated those adenosine receptors over years of use. For them, reintroducing the caffeine isn't shocking the system.
Oh, it is restoring their neurochemical equilibrium.
Precisely. It's the reversal of a chronic deficit, which naturally lowers their systemic distress.
That makes perfect physiological sense. Now let's look at the decaf group, because honestly, I would have expected them to show zero cognitive benefits and maybe even some lingering frustration from not getting their fix.
A lot of researchers would have expected that too.
Instead, they showed massive, statistically significant gains in episodic memory. They measured this using the MODRE test, which tracks verbal learning and memory over time.
The improvements there were undeniable.
Plus, they had vastly better sleep quality on the PSQI index. And surprisingly, their daily physical activity levels actually went up.
It represents a beautiful biological cascade effect. Decaf provides all the rich antioxidant polyphenols of the coffee bean without the circadian disruption caused by caffeine.
So they actually slept.
Right. Better sleep architecture, specifically more time spent in deep restorative sleep phases, allows for superior memory consolidation. The brain is literally moving events from the hippocampus to the neocortex more efficiently overnight.
And waking up fully restored naturally leads to increased physical energy and activity the next day. The bean itself is driving this virtuous cycle. So caffeine drives sharp attention, and the decaffeinated bean drives memory and recovery. But how is the bean doing this?
This is where the study goes microscopic.
Yes, they track the metabolites in both the urine and feces of the participants. Metabolites are basically the chemical exhaust left over after the gut bacteria break down what we consume.
Exactly. The urine analysis revealed the metabolism of the polyphenols. And what stood out immediately was the extreme inter-individual variability.
Meaning what, exactly?
Meaning, if you and I drink the exact same cup of coffee, the chemical output in our urine will look completely different. Your body might extract a massive amount of healthy polyphenols, while my body might extract very little.
Because my gut microbiome is populated by entirely different bacteria than yours.
Exactly. Your unique microbiome architecture dictates your ability to harvest the benefits of the bean. Now, when they analyzed the fecal metabolites, they uncovered a deeply complex trade-off for the coffee drinkers.
Trade-off?
Yeah, they had significantly lower levels of key neuroactive compounds.
Right, compounds like GABA, which is the primary inhibitory neurotransmitter that calms the central nervous system.
Correct.
And they also saw drops in specific indoles, IPA and ICA. Those are indole-3 propionic acid and indole-3 carboxaldehyde.
A mouthful, but yes.
And those are crucial compounds that protect the integrity of the epithelial lining in the gut barrier.
The fact that these protective, calming metabolites dropped is a vital nuance. It suggests that while coffee provides amazing systemic anti-inflammatory benefits in the blood, the digestion of the bean exerts a local stress on the gut environment.
Interesting. So it shifts how bacteria metabolizes essential amino acids like tryptophan.
Precisely. But the researchers didn't just measure the chemical exhaust, they identified exactly which bugs were thriving on this coffee diet.
Right. We always hear vague terms about good and bad bacteria, but this study actually named names.
Yes, down to the strain.
They found significantly elevated levels of Cryptobacterium, curtum, agarthella, and a specific firmicute strain, CAG.94.
Those specific strains are highly adept at breaking down complex plant compounds that the human stomach simply cannot digest on its own.
And then there is the absolute star of the show, a specific bacteria called Veillonella. To remember this, just picture a smooth vanilla coating blooming inside your gut. On day 21 of the reintroduction phase, regardless of whether the participant was drinking caffeinated or decaffeinated coffee, Veillonella experienced a massive, undeniable population balloon in the gut.
And that independence from caffeine is the critical mechanism here. It proves definitively that Veillonella is feasting specifically on the complex carbohydrates and the polyphenols innate to the coffee bean itself.
But how does a bacteria blooming in the dark of your colon change your sleep quality or your anxiety levels all the way up in your brain?
To map that exact mechanism, the researchers built an integration model, a Sankey diagram.
Like a flowchart.
Think of it as a complex causality map tracking the flow of biology. On the left side of the map, you have the gut bacteria. On the far right side, you have the behavioral outcomes like the anxiety and sleep scores.
And in the middle?
In the middle, bridging the two, are 9 specific metabolites.
Compounds like phenolic acids, caffeine itself, and theophylline.
Exactly. Let's trace the path of theophylline to see how this works. The diagram proves that the presence of Veillonella strongly correlates with the production of theophylline in the gut.
Okay, so the bug makes the chemical.
Right. And theophylline is a known phosphodiesterase inhibitor. It relaxes smooth muscle tissue and acts as a mild central nervous system stimulant.
So the chain of events is literal. The Veillonella bacteria break down the coffee bean and produce theophylline as a biological byproduct.
Yes.
That theophylline crosses the intestinal barrier, enters the bloodstream, travels up to the brain, crosses the blood-brain barrier, and binds to receptors that directly alter how anxious or how sleepy you feel.
It is a profound, literal chemical communication from the gut to the brain. The coffee isn't just a drink. It is the raw material required for this internal manufacturing process.
It's like the gut-brain axis is a strict airport security checkpoint. And the coffee polyphenols are VIP passengers that the gut bacteria intentionally wave right through to the brain.
I really like that analogy. The bacteria are the ultimate gatekeepers, determining exactly which chemical signals are allowed to be sent upstairs to the brain.
All right, let's lock in this final brew phase with our last quick recap.
Let's do it.
Bullet 1. Caffeine restores neurochemical balance for habituated users, reducing anxiety and boosting attention.
Yep.
Bullet 2. Decaf profoundly improves episodic memory and sleep quality because you get the bean's benefits without circadian disruption.
Exactly.
And bullet 3. Gut bacteria, like Veillonella, literally digest the bean to manufacture 9 specific metabolites that travel directly to your brain to alter your mood.
So if you had to choose right now, based on your own life goals, would you prescribe yourself caffeinated for attention or decaf for memory?
Man, I'd probably still take the caffeine, but I'd really think about throwing a decaf in the afternoon.
That's a solid strategy.
So what does this all mean when we step back and look at this entire base break brew journey? We see a much more nuanced, mechanistic picture of what coffee actually is.
We really do.
If you don't drink coffee, you enjoy a naturally stable emotional baseline. You're free from the vascular cycles of withdrawal, and you maintain a distinct, highly stable gut barrier profile.
But for the habitual drinkers, this study validates the habit in a major way. You are not just feeding a caffeine addiction, you are actively ingesting a potent compound that fundamentally reshapes your immune response and suppresses systemic inflammation.
You're lowering your internal fire alarms.
Exactly. You are feeding a specific microbiome architecture that actively supports cognitive processing. And crucially, if you choose to switch to decaf, you still harvest the vast majority of those microbiome benefits, plus the added bonuses of enhanced episodic memory and deeper sleep.
It really forces you to respect the sheer complexity of the bean. It's a profound modulator of human biology.
It absolutely is.
Yeah.
But this raises an important question. If we look really closely at the causality loop we just mapped out.
Oh boy, I feel a paradigm shift coming.
Well, we just established that our unique individual gut microbiome dictates exactly how we metabolize the coffee. And we established that those resulting metabolites, in turn, travel to the brain and alter our mood, our anxiety, and our baseline sensation-seeking behavior.
Right. The bugs make the chemicals, and the chemicals make us feel a certain way.
So tomorrow morning when you wake up and you feel that undeniable, almost impulsive urge to brew a fresh pot of coffee,
Yeah.
is it really you making that conscious choice, or is it your Veillonella bacteria actively manipulating your brain chemistry, sending targeted chemical signals up the gut-brain axis simply to ensure that it gets its morning meal of polyphenols?
Oh, wow.
Makes you think, right?
Are we actively choosing to drink the coffee, or is the microbiome driving the host to fetch it? That is mildly terrifying, but absolutely brilliant.
It's the ultimate biological puppet master.
It really is. Well, the next time you take a sip of that steaming dark roast, just consider the millions of microbes cheering in your digestive tract. Thank you for joining us on this deep dive into the source material. Keep questioning the biology behind your daily habits, and we will catch you on the next one.